Okay, good afternoon, everyone. It is 3:02. I do see we're still missing a few participants, but we're going to go ahead and get started. That way we can utilize as much of our time as possible today. So welcome to the SAS Viya Transition Interactive session. Um, this is our first session like this. So please be patient and kind with us. We may have some tangles and kinks along the way that we're going to have to work through. But we are excited for this new offering. So just some administrative announcements before we get started today. This session's meant to be collaborative and interactive, so it will work a bit differently than our other sessions have. We may utilize the Zoom breakout rooms, which it sounds like Oren would like to do that throughout our session. A CCSQ DNA team member will be available for support in each room. If you have questions, feel free to ask them verbally in our Zoom or use the raise hand feature in our Zoom. That's at the bottom of your Zoom toolbar if you're having trouble finding it. It's either going to be in your like React option, it's like the little heart, or there's a caret that you can click there, or sometimes it's just situated next door, depending on your Zoom type. And if you have trouble joining a breakout room in general, please write us a message in the Zoom chat and we can try and get you into whichever one you need. Portions of this meeting, including right now, will be recorded and then made available to the CCSQ DNA portal. And then please make sure to leave us feedback in the end. There's going to be a survey. There's a question in the survey itself that asks for any feedback and suggestions. Please do that so we can make sure that we can continue offering great sessions that are meeting everyone's needs. So with that, I'm going to go ahead and stop sharing my screen and pass things over to Oren so he can kick things off for us today.
Excellent. Thank you. Okay. So what we're doing today is we have a bunch of exercises prepared for you. And I put the link in the chat. I'm going to put it in the chat again. What you need to do is you're going to go here and then you're going to clone this notebook to your own user folder. And the way you do that, you go to File, Clone, and then you can change the name, you can do something else like that. You go to Browse, you go to For You, and then in Suggested, your user folder should show up, or otherwise there'll be a reason it should be something you can save to. If I wanted to clone there, I would hit that, and then you hit the clone button, and then you'll have your own copy of this. And for this exercise, you're going to be working with 3 tables. All these tables can be found in the schema public data, and all of you should have access to it. In the future, we're going to migrate tables to CDR-PSA community. That's getting set up as we speak, so we didn't want to do that for this. The first table is IS1 AMP. That is information about employees. The IS1 step talks about the department. IS1 mtrain talks about the information about their training courses. And you can use SQL commands to examine these tables more closely. I do have described for you in the notebook, but if you want to do anything else, go for it. About this is meant to be done in SQL, so questions should be answered only using SQL. Try to answer questions using a single query instead of many queries, and CTEs are allowed. For questions, if you have questions, you can either ask them in the chat, or if nobody's talking, feel free to chime in. And if somebody is talking, then just raise your hand and we'll get you in order. Get your raise your hand in. And based on your questions, we will be creating breakout rooms. So if people want to learn more about certain things, they have the opportunity to do so. Excellent. And if there are no more questions, I will let you guys get started. You can stop recording now. You're looking in the chat. Excellent. Thanks for getting the recording. Also, can we close the breakout rooms, please? I don't think I went in any of them, but just to make sure. So, show of hands, how did people do on this exercise? What do people think? Did people get through it all? Okay, I see some thumbs up.
I made it to the very last one. I haven't seen these yet, so
Excellent. Okay. So for question number one, exercise number one, this was to write SQL code to print out a list of employee names and manager IDs in the analytics department, sorted by the field employee name. So for this, you could either do one or two things. Either you could go for the department name and then you need to grab stuff from the department one, or you could look at all the tables and figure out which one is the analytics department and just use the employee table. But basically what you want to do is you want to do something like code like this. This is the code that I use. I wanted to actually use the employee's name. And what I do is I have employee name, manager ID. I'm grabbing from the employee table. And then my where statement, I am going to do a subquery. And you could do a subquery, you could do a join. I did it with a subquery. And you're just going to do where department name is in select department name from this table, where the department name is data analytics. And I'm ordering by employee name. And basically, subqueries lets me basically see what's in another thing, in another table. So here I am just looking at where that department name, where it's in any of these, as long as the department name is that. It shouldn't probably be a one-to-one relationship. And yeah, these are the answers I'm getting. And that is exercise one. It was supposed to test your ability to do wheres, to be able to sort, and to be able to do a basic join. Are there any questions? Any comments? Okay. For number two, we were going to write SQL code to determine the number of employees and average salary for each department. So here the idea was we were going to do aggregation. And what we were doing is I was doing a join here. I want to do department name instead of department ID, but you could do department ID. That's why I need to do my join. But basically the main things that you need to understand are how to do aggregations. Those are counts, those are means, and I did the round function, which round because it is dollars. You get to be things like that. So you do your count to get all your employees. Here this does the mean of the salary, so I'm going to round it. I'm going to define it as average salary. Here I'm dividing it as employee count. And then I am doing a join with community department. So I know that I get the department name and I'm doing it on department ID. And I'm just grouping by ID and name. And probably don't need Nippo, probably could do just have done one, but yeah, I don't need both of these. I could have done one of them. And this was just supposed to show a basic aggregation stuff. For number three, this was a write SQL code to determine which departments have more than 10 employees, and then print the number of employees and total salaries. This is a bit more confusing because it requires you to use having. And where and having, they're both used for filtering. Where is used, it's used on single rows, it's used before aggregation. Having is used whenever you're doing aggregation. So if you're aggregating something, that's when you're going to use the having, and the where is going to be used on individual rows. And what we're doing here is, since we are grouping by department ID and department name, this having means that we are looking at employee ID, and we're saying whenever this group has more than 10, that's when this happens. And then aside from that, we're still doing our count to get that information. That's our basic aggregation before. This is from total salaries, also from before. And we're doing our join as right here. And then we just use that having, and that's going to get us our answers. And you can see right here, there are two departments. I see we have a comment in the chat. Yeah, so using where and using having, just as we said before, having you want to use when you're on aggregated data, it's going to be on the group by mainly, and where is going to be used just on general, it's going to hit individual rows. So for question number 4, we want to find out which employees have no reports. So yeah, basically Q isn't a manager.
Hey,
And
Oren, we've just got a question in the chat. I don't know if you want that before you continue moving on.
the where and having.
Yeah,
Yeah,
did you just
sure.
get to that one?
Yeah. We just talked
Okay,
about that
cool.
one. Yeah, thank you. So for this one, this is going to require subqueries, and it's going to require the not in function. So basically, the idea is what you can do is sometimes you can say whether you can do a subquery, you can do whether something is in that other query, but you could also do when it's not in that query. And here what we're doing is we're looking at this employee table and we're seeing who does not have a manager, right? So we're grabbing all the manager IDs from there, and then we're saying which employee ID is not in that set. And that's the basic idea there, to be able to understand in and not in. And also understanding how subqueries work. For question number 5, and this was a bit more challenging, this requires the use of Windows functions. And if you're curious about Windows functions, we talked about them in detail in lesson number 7. And the idea behind them is that we talked about it in number 7. What we have here is we are going to use the rank function. And what we're doing is the way we create that rank function is we're going to use a Windows function. We're going to do a partition by, and that partition by, it sort of works like a group by. And so it's going to take everything in the department ID. Partition by and group by are a bit different because if you just do a group by itself in a Windows function, I believe it only looked at the first partition, which is problematic. So you want to do partition by and not group by in a Windows function, but basically this is taking whatever is in department ID, and then it's going to order it by salary descending, and then it's going to use this rank function, and it's going to define it as rank. And as you can see, we run our Windows function, and you can see that we have 1, 2, 3, 4, it's all going down, and we go all the way down here. And yeah, it is ranked. And because I'm ranking, because the partition by is by department ID, it goes back to 1 when I get to different departments. If I go down here, you can see that department ID, department ID 2, the ranks are reset to back to 1. And again, if there are any questions about Windows functions, we talked a lot about them in lesson number 7. And then there is exercise number 6. And exercise number 6, this is the one. I might have a question in the chat. Yes, so for exercise number 6, you want to define the total salary for each manager, including both direct and indirect reportees. So that's including employees that report to the field report to them. So basically, suppose you have a grand boss. For that grand boss, you would want the grand boss, the boss's direct report, and then basically the manager's report, and so on and so forth. And the idea behind this question is we wanted to show one that it can be solved in SQL, but it's probably easier to solve using Spark or R, because Spark SQL is not really designed to solve this problem. What you can do in some other languages is you can use a recursive CTE, common table expression. And basically what that does is it basically lets you create some commands using a if statement, and basically it lets you run them at each level. So like you would be able to run it and it would tell you which rankings are in. So basically you would just run it at that first level, and then you would include, I want to say it's a level, that's what it's called. It's called a level, and you would say level is one, you would just add levels and it would go through things. Spark SQL does not support it, which means that Databricks SQL does not support it, which means that doing this in Spark SQL is extremely difficult. And that's just one reason why you probably want to learn R and Spark. But the idea behind this, if you have to solve it in SQL, is you want to keep on doing subqueries until you can get the manager. So what you want to do is you want to find, at the first level, you find each employee's ID by their manager ID, and you would just sum it up, and that's your first level. And then what you do is you would take the manager ID of those reports, and you would grab all of those, and then you would try and join that to the employees table, and so on and so forth. And the code that we got to do this for looks something like this. There's a few ways you can do it. So what we're doing is we're grabbing the employee ID, we're grabbing the employee name, and then we're using a case statement to add up all the salaries. And you need to use a case statement to add up all the salaries because at some levels, you're going to have nulls. So the first line bosses, they're only going to have one level of report. So for them, second salary and third salary is going to be null. And if you add a number to a null, you get nulls. And that also goes for the second level bosses are going to have only first and second, they're not going to have third. It's only the big bosses that are going to have all three, so they would get numbers. And that's why you need to use a case statement. And then what we're doing is, so we start with salary, and that's just going to be the else because everyone has that, because everyone has one level of salary, right? And then what we're doing is we're doing a left join. We're basically grabbing the manager ID. I'm grabbing any employee ID because it doesn't matter to me what I'm doing a sum. I just need to have one. And then I am going to group it by manager ID. I'm gonna join employee ID, the manager ID, and that's gonna give me my first level of reports. And then for my second level, we're gonna make an even more complicated thing. Basically, we're going to, I'm calling this second salary manager ID. I'm doing a left join on a table, on that same employee table that has everyone, has all those employees grouped by manager ID. So basically what I'm doing is I'm taking every employee's manager, I'm summing that as a salary, and then I'm going to join employee ID, the manager ID. And that way I'm comparing everybody's manager to an employee. And I group that by manager, and that's going to get me the second level of people. Because basically that's going to be everyone's thing. And then for the third, same idea, only a lot more complicated for the third. You do all these joins, and I'm in your where statement. I have where the employee ID where they actually are a manager. If they're not a manager, I don't want to have them show up. And I'm grouping by employee ID, employee name, order by employee ID, and we have total salaries. It should look something like this. And then what you can do, you can also use CTEs, and you can do something like this. So here, that's that first query in a CTE right there. And you can see I'm calling it by that with statement, and it's just this query right here. That's the first one. This one is the same as the second one. That one's the same as the third one. And then instead of doing all that code, I just do a left join on the CTE itself, do it by employee ID, and it looks a lot cleaner. It's probably a lot easier to understand this code than the code above, where it's a bit more complicated. And yep, that is how you would solve these. Number 6 took me a really long time. When my teammates did it using Python, it took them a lot less time. So again, it just summarizes why using PySpark or something else might be a better solution than just using SQL to solve everything. And yep, that's the exercise. If there are no more questions, I will hand it back. All right.
Orin, are you ready to move on to the poll at this point?
Yes.
Okay, cool. So I'm gonna go ahead and stop recording now.